Hello guys, welcome back to my channel. It's me, SDSESTA, and so today we will be solving the maximum count of positive integer and negative integer. Today's problem of the day on LeetCode. So let us see what the question says. We have an array num sorted in non-decreasing order. We have to return the maximum between the number of positive integers and the number of negative integers. That is, for example, let's say in this example, we have three negative integers and three positive integers. We have to give out the maximum of them, that is three. In this one, we have three negative integers and two positive integers. Remember, 0 is neither negative nor positive, so you have to give out the maximum of them, that is 3. In this one, all are positive integers, so 0 negative and 4 positive. So the maximum would be 4. So one approach of this could be just searching from the zeroth index to the last index, finding the last occurrence of the negative integer and the first occurrence of the positive integer, and giving us the answer. This will give us a complexity of O of n. But we know that whenever a question comes up of searching in an integer, like for example, like we are in any given array. Let's say we have an array like this, for example, let's say we have an array 1, 2, 3, 5, and 6, and we have to search 4. We can always use binary search. In whenever the point of and the question of searching comes up, always think about binary search. So we can apply the same thing. So we have to binary search the element which is first element which is less than zero, that is negative, and binary search the first element which is a last element which is less than zero, and the first element which is greater than zero. So we can just apply two binary searches for that. So for example, let us do first for the first element which is less than zero. Okay, so it will be this particular section of the code. So for example, let's say we initialize the last pointer, a low pointer, which is L, which is equal to 0, and high, which is n minus 1. And so it will be pointing, let's take this example, for example. Okay, so it will be pointing at minus 3 and 2 in the beginning. Okay, then we will do binary search. So we know in that we first take up the middle element. So it would be minus 1 in this scenario, because no, it will be 0 in this scenario, because L is currently 0. Okay, let me just write it over here. Okay, okay. So we know L is currently 0 and my age is currently 6. Okay, because there are 7 elements in this. So 0, 1, 2, 3, 4, 5, and 6. Okay, so my mid would become 3. Okay, so my third element, which is a third element, the third index is 0. Okay, so now I would see that if my element is currently 0 and I have to find the first negative element, so my first negative element will be to the left of this 0. Okay, because all of this is in sorted increasing order. Okay, so it is in increasing order. I am at 0, so I need the first negative element, so it will be to the left of this 0. So I will update my age to I will update my age to mid minus 1, because now I have to search to the mid of to the left of this mid. So my age will become to the mid of this one. So this would now become 2. Okay. Now we'll again run the loop. So 0 plus 2 by 2, which is 2 by 2, which is 1. So I will be looking at my index at 1. So 0 and 1. So this is minus 2. Okay. And so simultaneous, so I have minus 2. So this is a negative number. So now I know that so now I know that my number which is negative. So my last, it may be that this minus 2 is my last negative number. So it can also be that over here it will be 0. So it will be minus 3, minus 2, 0, 0, 0. That can also be the case, or it can be the case given like minus 3, minus 1. So I can safely say for now that my last negative index, okay, the number at the index at which I have my last negative number, and from this index onwards there will be only positives or zeros. So my last negative index would be my mid, okay, which is 1, because I've gotten a negative number. Okay, so now I will again now run the loop and see. Now I will see if is there a negative number at at an index greater than this current index, which is my mid. So I will update my left to my mid plus 1. Okay, so now it will become 2. So now 2 plus 2 by 4, it is 4, and by 2 is 2. So now mid is now 2. Okay, so now I'm looking at index equals to 2. So 0, 1, and 2. So my this index is 1. So now I know that minus 1. So my last negative index will be maximum of my previous index and the current index. Okay, so because I have at minus one, my previous index was made, which was one. Okay, this was one. Okay, before. So now I'm at two, which is also negative. I'm at index two, which is a negative index. So this would be two. Okay, so this is my current last negative index. Okay, so now I will update my left because now it can also be the case. Like I said, we are at the negative number, so it can be the case that I have another number which is also negative to the right of this index. Okay, so I will update my left to mid plus 1, which is 3. Okay, but now I will see my basic condition of binary search is my left pointer should always be less than or equal to my right pointer. That is my high pointer. Okay, but now this condition fails. Okay, so I will get out of my loop. So my last negative index will be at index 2. And we can confirm that from this example that it is 0, 1, 2. Yes, my last negative index is at index 2. Okay, so we can just code that up over here. If my mid would be L plus H by 2, my num, which is number at this index, if it is less than 0, then there is a possibility then that there is another negative number to the left of this index. So I will do mid plus 1, and I will say that my last negative index, that is the index, because it is a possibility that there is a negative to the right of this index, but it can also be that this is the number which is my last negative number. Okay, so it will be maximum of my last negative index, which is like index which I've gotten previously. So previously I will assume that there are no negative numbers. So my last negative index will be at this one. Okay, we can see like for example, in this number, my last this negative index would be nowhere. I have no negative number, so my last negative index will be over here. Okay, so minus one, maximum of minus one, and my current. So it will be pointing to a place. Okay, pointing to my last negative number, index of the last negative number. Okay, and if it is greater than 0, then there is a possibility that I have a negative number to the left of this index. So my h will become mid minus 1. Okay, so this is how we will find out the position of my last negative index. Now we'll have to find the position of my first positive index. Okay, number at which I have the index at which I have my first positive number. Okay, so uh, we have, so I've already set my LNH, so I don't find any issues. I get any issues when finding the next negative index, first positive index, sorry. So now I will see again. Um, where's this? Okay, so now I will see I will do the same thing. So if I'm at, like, for example, let me take this example. Okay, so let me just do it with this example only. So let's say if currently my mid would be at this index, which is 0. Okay, my mid is L is 0. Okay, L is 0. H is n minus 1, which is 6, and my mid is 3. Okay, my last negative index I've gotten to be what was it, 2. Okay, now I have to find my first positive index. Okay, I will just write it my currently as first positive index. Okay, so which it is currently at n, because I'm assuming that there are no negative number, there are no positive numbers, all are negative, so it will be pointing to somewhere around this. Okay, so I'm pointing to somewhere like outside of this array. So if it is at n. So my mid is now 3, 0 plus 6 by 2, which is 3. Okay. So now I would say that at this index, which is 0, okay, is it greater than 0 or this less than 0? But it is equal to 0. So that is a possibility. Now, as this is in a sorted increasing order, so I will have my positive number to the right of this index. Okay. The right of this index. So I will say my left will become mid plus 1, which is now 4. Okay, so and so this is not negative nor positive, so I cannot solely say that my first positive index is this index or not. Okay, so I will again run the loop. and my L will become mid plus 1. Okay, L became mid plus 1. So now we'll again run the loop. 4 plus 6 by 2, which is 10 by 2, which is 5. So now we're looking at index 5 because I'm pointing at this is my L, this is my H. So my now mid is 5. So it's 0, 1, 2, 3, 4, 5. So I'm pointing at 1. Okay. So this is a number which is greater than 0, which is a greater than 0. Okay. So there is a possibility that I have another number which is still positive but which is to the left of this. Okay, I have a possibility that I have a positive number. Okay, which is the left of this. Okay, so but I can say for now my last positive index would be my mid. Okay, so my mid which is 5. Okay, but there is a possibility that my current index, I have one more positive number, which is the left of this index, okay, which is mid. So I will update my high to mid minus 1, which is 4. So 4 plus 4, okay, so 4 plus, so I am currently pointing at 0, 1, 2, 3, 4, which is my L. Over here I have my L, and over here also I have my H. So 4 plus 4 by 2, which is 8 by 2, which is also 4. Okay, so I'm at 0. So now I will say it is equal to 0. So there is a possibility that there is a number to the left of this 0 where I can get my first positive index. Okay. So I will update my L to mid plus 1, which is 5. And I will run the loop again. But my binary search condition is that L should always be less than or equal to H, which does not satisfy, so it will break out of the loop. So the same thing we have done over here. Okay, so if my L is less than H, I will find my mid, I'll find the num. If it is less than or equal to 0, that means I can find my first positive index to the left of this index. Okay, so it will be mid plus 1. And if my number is greater than 0, then I will update my. So there is a possibility that there is a number which is still positive but to the left of this index because it is sorted in an increasing order. Okay, so it will be my H mid minus 1. So and my first positive index, so there is also a possibility that now this is my positive index, right? I'm at a number which is positive. So it can be that this is my first positive index and all numbers to the left of this number are either zeros or negatives. So it will be the minimum of my first positive index and my current index which is mid. Why minimum? Because I'm assuming that currently I have no negative numbers, no positive numbers. Okay, so my index is at over there at this position. Okay, like at uh, after this 2, which is n. So it will be from n, minimum of n, and current index. Okay, so it was like 1. Okay, now there's a possibility that, for example, let's say over here it was also a 1. Okay, so I would be seeing that this 1 is there, but there is a number which is also positive to the left of this. So I will move to this number. Ultimately I'll find this number. So it will be minimum of this index and this index. So it is this index because I need the first positive index. Okay, so we have this. Okay, this works. Okay, now I'll find the answer. What is my answer? So I now what I have gotten till now. I've gotten the indexes at which I have my last negative number and the indexes at which I have my first positive number. Okay, which is not 0. So I will now see if my first positive index is not equal to n. That is, that I have an index which is in my array, which is so my positive numbers does exist. So it is not like I have no positive numbers because n means that there are no positive numbers. So my answer would become maximum of my current answer and my n minus first positive index. This gives me my number of positive numbers. Okay, so if I am at a index, let's say this is my index. Okay, this was index we found out as what was it, 5. Okay, I'm at index 5. So 5 minus n, which is 7. So it's 7 minus 5, so it is 2. So I have two numbers over here. Okay, so this is simple mathematics. So this is my number of positive. This represents my number of positive numbers. Okay, so maximum of 0 and this will be 2. Now to see is do I have so this gives me number of positive numbers. Okay, so my answer currently stores the number of positive numbers. Okay, so now I have to see if my last index plus 1, this gives me number of negative numbers. So my answer would be maximum of the number of positive numbers and number of negative numbers. Currently, the answer stores number of positive numbers, maximum of this, number of negative numbers, which can be got by an index plus 1. Okay. And so we can see out to see. I don't need to do this, but I did it so I can find if there are what are my last negative indexes and what are my last positive indexes to check my code. Okay, you can comment this out also, and yeah, then return my answer. So I had submitted this before. I will show you it works. The algorithm works entirely. Okay, and yeah, so this is the code. If you have any doubts, please comment below and let me know. Okay, so thank you. Bye bye.